Friends, by the way, once again I am Dr. Sajid Ali. So today I am going to teach on the topic of defects. So first of all, I would like to mention what are the defects, how they will be created, and what is the difference between the Frankel defect and the Schottky defect. So first of all, I will mention what is defect. So these are the irregularities or deviation from the ideal arrangement. As we know that in the solids, the constituent particles have a particular arrangement. This arrangement may be in the form of a cube, in the form of a square, or any shape. So if there is irregularities in the deviation, or if there is irregularities or the deviation from the ideal arrangement. So ideal arrangement may be in the form of a square. If there is irregularities, means from the ideal arrangement. Suppose if any constant particle will come in between the square or above the lattice side or lower the lattice side, then the deviation will occur. So this irregularities basically is known as the defects. So defects may be of three types. Number one, stoichiometric defect. Number two, non-stoichiometric defect. Number third, impurity defects. So now, first of all, I would like to discuss here that is the stoichiometric defect. So the stoichiometric defect may be of following types. Number one, interstitial defect. Number second, vacancy defect. Number third, Schottky defect, and number fourth, Frankel defect. Interstitial defect. This type of defect are found in the covalent compounds. So we will study what is interstitial defect. So with the help of this diagram, we can understand what is the interstitial defect. So basically this is a diagram in which we can see here there are the four constituent particles, and when one extra constituent particle that will be present in the interstitial site, so then this type of defect is known as the interstitial defect. So you can better understand here that the density will increase. Now we will take another defect which is also found in the covalent compound, that is the vacancy defect. So in the vacancy defect, what will happen, as you can understand by this diagram, so there is the constituent particle. When some constituent particle will miss from their places and there is the creation of the vacancy, means the density will decrease. So such type of defect is known as the vacancy defect. So in vacancy defect, generally what happens, you can see here, so there is the creation of the vacancy, means some constituent particle will shift from normal site to another site, or the normal site or the lattice site will remain vacant. So this type of defect generally found in the AGBR. So next defect is known as the Schottky defect. So this type of defect is basically found in the ionic compound. So here is the diagram. By the diagram we can understand here there are the cation and anion. So they are, first ion is known as the cation, and the second anion is which is the negative charge, which having the constant particle which is having the negative charge, that is known as the anion. And again this is cation, again this is anion, cation, anion. So the main thing is that what you can understand here, cation have a smaller size, whereas the anion has the larger size. So they are in the sequence. So generally what happens, if one cation will miss from their places, the same number of the anion will also miss from their places. So generally overall the electrical neutrality will be maintained. So there is the missing of the cation, missing of anion. So that is why the density will decrease in the Schottky defect. So such type of defect is also known as the Schottky defect. Now we will come on the Frankel defect. So this is also found in the ionic compound. This defect is also known as the dislocation defect. So in this defect what happens, the cation will shift from the lattice site to the interstitial site, as we can better understand here with the help of this diagram. So this is the side of the cation. So this cation will shift from lattice side to interstitial side. So then what will happen? The density will remain same. There is no change in the density. So this type of defect also found in the ionic compound like Ag, Cl, Agbr or Agi. Now will come another type of defect that is known as the non-stoichiometric defect. So these defects may be of two types. One is the metal excess defect and the second is the metal deficiency defect. So in case of the metal excess defect, we can understand this defect by this diagram. So there is a NaCl crystal, or around the NaCl crystal the sodium vapors are present. Then what will happen when the sodium vapor when the sodium vapor will deposit on the surface of NaCl crystal, then the metal will be in excess. Then what will happen? The chloride ion from the crystal, they will come out and the electron will enter into the crystal. So when the electron will enter into the crystal, there is the creation of the F center. So these are the center which basically responsible for the color of the compound. So when the electron will move from low energy level to high energy level, then they will give the color of the solid. So this type of defect is known as metal excess defect. Now we will come on the next defect that is known as the metal deficiency defect. In this defect, you can see here the metal will be in the less amount and oxygen will be in the one ratio. Means the ratio will be different. That is why it is known as the non-stoichiometric defect. Here the metal will be in less amount and the another atom will be in the higher amount. Now the final defect is known as the impurity defect. This type of defect is found when NaCl have some impurity of the SrCl2. So what is SrCl2? It is strontium chloride. So generally what happens when the one atom of the strontium will replaces the two ions of the sodium, then the vacancy of one sodium will be occupied by the strontium and the other vacancy will remain vacant. So when there is a extra vacancy, so this type of defect is known as the impurity defect. So thank you friend. So this was my today's presentation. I hope that the next presentation will be uploaded soon. I hope that all of you will like my videos, and thank you very much, and please subscribe me. Thank you very much once again. Hope